Hello everyone. So this is the architecture which we are going to follow in our today's lab for Amazon VPC. So we are going to deploy one virtual private cloud, and inside it we will be deploying two subnets, out of which one will be the public subnet and one will be the private subnet. EC2 machine inside the public subnet will be able to access the internet, or you can access them using the public IP with the help of internet gateway. And during this lab we will also see how to modify the route tables so that we can access the public machine from the outside, as well as how we can reach out to the private EC2 instance by using the public EC2 machine as a jump box. And during the lab we will also see what are security groups and how to modify them to restrict or allow the traffic through various EC2 ports. Here are some points which will help you to understand the VPC in a better way. Here I am in my AWS console home. So click on services, and from the left hand side menu scroll down, and under network and content delivery go to the VPC. Here you can change the region where you want to deploy your resources or your VPC. So here I am selecting US East 2, that means Ohio region. I will hit on create VPC. Here I have two options, one is VPC only and one is saying VPC and more. VPC and more is kind of a semi-automated way where it will create a VPC for you, and whatever the subnets and route tables are required, it will create for you. But as we want to learn everything from the scratch, so I will be going with the VPC only option. Here, give your VPC some meaningful name. In many organizations, what happened? They implement some policies in various cloud like AWS, Azure, Google Cloud, etc. that you have to adhere to some naming convention, and if you don't follow that, you won't be allowed to deploy that particular resource. Say something like VPC and the application name and the region name and something like that. So let me give some meaningful name. Let's say VPC, and this for the web application, and this is for the Ohio regions OH and 01. Here I will be selecting only IPv4 CIDR block, and here whatever the CIDR we want to go with the for our VPC. So here I will be providing 10.0.0.0/16 as per our lab architecture which we discussed earlier. Here I will be keeping tenancy as a default, and here you can add various tags. Tags is basically a meta information about that particular resource, and it is a very useful and efficient way in which you can segregate your resources when it comes to your billing or your resource utilization, etc. So suppose any team XYZ is responsible for the maintenance and for using this resource, then you can give it a team name, and also this resource is used by this particular web application, you can give that as well. So it depends on your requirements and also to the company policies. Here also many organizations implement tagging policy where you have to adhere to it and you have to give the particular tags and the respective values. And if you are not going to give it, you won't be allowed to create the particular resource. So as of now, to keep things simple, I will remove all the custom tags and only will keep the default one, that is provided by Amazon. That means name is equal to the resource name. And now hit on create VPC. It will take a minute or so to get our VPC deployed and be ready for us. Go to your VPCs. I can see my VPC has been created. And with our newly created VPC, I can see one more VPC which is already present. So what happens? AWS creates one VPC by default in each region so that it's easier for you to go and deploy your resources. But as we don't need this and we want to learn everything from the scratch, so we'll be deleting this VPC and only using our custom VPC. And if I go to the subnets, I can see three subnets in each availability zone which is associated with our default VPC. You can also rename your VPC by clicking on the pencil icon and give it a name of your choice. And also on selecting this VPC and click on action, and here how you can delete the VPC. So acknowledge and confirm by typing delete default VPC and click on delete. Also, if you go to the subnets, you won't find the existing subnet. So here we will be creating a new subnet under our newly created VPC. Once you select the VPC, it will give you the further subnet settings. So here you can give it a name to your subnet. So we will be naming it as a public subnet as per our architecture which we discussed earlier. You can select any of the availability zone. So as of now, I will be going with the US East 2A availability zone. So here is the simple way in which you calculate how many IP addresses will be available in a CIDR block. Give the CIDR block for the subnet as per your choice, but it should be a part of the VPC CIDR block. We'll go as per our architecture and we'll hit on create subnet. Here are a few points about private subnet. Now we will create private subnet. So again hit on create subnet and select our VPC. And again give it a meaningful name. This time I will be selecting availability zone as 2B. And give it a CIDR range which should be a part of VPC CIDR range. Also, it shouldn't conflict with our public subnet CIDR range. And hit on create subnet. So now we have both public and private subnet in place. Now we will create EC2 instances for the respective subnets. So from the services menu, scroll down and go to the compute, and from there go to the EC2. And also you can bookmark EC2 by clicking on star, so it will start appearing as your favorite in your console home. Here are some points about EC2. Now this is EC2 dashboard. You can see the instances running as well as the placement group, instances, etc. and auto scaling group, so which we are going to talk later. But as of now, create on launch instance. I will be naming it as a EC2A as per our lab architecture. and then I will be choosing the AMI. AMI is Amazon Machine Image. So basically it's a OS image containing operating system and some predefined softwares. So we will discuss about AMI in some other lecture. So I will go with the Amazon Linux 2 AMI. This AMI is eligible for the free tier. And then I will be choosing the instance type. I will be going with the T2 micro, which is also eligible for the free tier eligible, as you can see it on the screen. Now I have to select a keypair login. So for this region, I don't have any existing keypair in my account. So every region, so when you can create a keypair login, you can use it for other instances as well in the same account and in the same region. So I will be creating here a new one. Give it a some meaningful name. Keypair type, I will be going with the RSA. And private key file format, there are two options. One is the PAM key and one is the PPK. So PAM key mostly you use when you do SSH from the Linux machine, and PPK will be used by the PuTTY software, which is a third party software which you can use it in Windows to log in or to SSH into the EC2 machine. And also you can convert PAM key to the PPK key using the PuTTY key file generator. I will go with the private key file format as a PAM type because I will be using the same key to connect from one EC2 to another EC2 machine, and I will be converting this PAM key to the PPK key, which I can use with the PuTTY using the PuTTY software. This I am going to show you. So click on create key pair and it will download a PAM key file in your workstation. So hit on create key pair. Now in the network settings, click on edit. So here I will be, you can select the VPC and the subnet. So as per the diagram, EC2A should go in the public subnet. And I will be enabling the auto assign public IP, which will be assigned by AWS. Otherwise, we have to associate one elastic IP to it so that we can connect to this machine using the public IP. Here are some points about security group. Next comes the security group. Here I will be creating a new security group. So security group is a firewall in which you can filter the traffic at the TCP IP layer on the respective ports to the EC2 instances. In the security group, you can only allow the traffic. Rest of the traffic which you have not mentioned will be automatically denied. Here our EC2 launch instance wizard is giving us an option to allow the SSH traffic from anywhere on port 22. Here you can also define a custom CIDR range, which we are going to see later. But as of now, we are going with the anywhere, that means 0000 CIDR range, so that we can SSH into the machine using the public IP. Now scroll down further. give some name to your security group and as well as the description of your security group. Here you can add further rule like for HTTP traffic or other traffic, etc. depending on the port numbers. Here I will be keeping other settings as default, and I want the number of instances which should be equal to 1, because as per our architecture there should be one EC2 instance in the public subnet. Here you can see the free tier information which says free tier, your free tier eligibility is 750 hours per calendar month for the EC2 instance. If you have two EC2 instances running all the time, then it will be 750 by 2 hours. So hit on launch instance and go to the instances, and as you can see our EC2A is initializing and it will take couple of minutes to get ready. And here you can see various information like what is the private IP address, what is the public IP address, what is the network it belongs to, etc., storage, other things which we are going to discuss in other lectures. Now we will be creating a EC2B machine which will be in private subnet. So here I will be going with the similar configuration which I use for EC2A. Keypair login we have already created for the previous machine, so we will be using that one only. I will be selecting this one and edit network setting. Here I want to place the machine in the private subnet, so it's fine. And to private EC2 we don't want any public IP to be assigned automatically, because we'll be doing SSH from EC2A to EC2B and it shouldn't be reachable directly over the internet. Here give your security group a name and also update the description. And this SSH default rule I won't be needing as of now, so if required we will be creating it later. So as of now I will be removing this. Rest of the configuration settings I will keep it as a default and click on launch. So here one EC2A is running and EC2B is currently initializing, so it will take a couple of minutes and now you can see it's running. Here are some point about internet gateway which you might want to read it. Now from the services menu go inside the VPC and it will take me to my VPC dashboard, and from the left hand side menu I will go to the internet gateway under virtual private cloud. So here I will be giving some name and click on create. Then I will be attaching it to a VPC. So internet gateway is a VPC component which is highly available and which allows communication between the VPC and the internet. And also there is no charge for it, and you can add only one internet gateway to each VPC. Now click on attach VPC and select our VPC and click on attach internet gateway. Now we'll go to the route tables and modify the routes so that we can access our public EC2 machine, that means EC2A. So here I will be creating a new route table. Let's name it as a public RT or public route table for better understanding in the future. Select our VPC and click on create. Here I will be creating one more route table. So this one will be the private root table. Select the VPC and hit on create. Now we will be attaching our or associating our root tables with the respective subnet. So I will be associating public with the public subnet. So go to the subnet association by selecting the root table and click on edit subnet association. Here select the public subnet and click on save association. Now we will do the same exercise for the private root table and will be associating it with the private subnet. Now our root table association is in place. Now we will be defining the respective roots. So select the public root table. So first select the public root table and go to the roots. And here you can see one root is already present that mentions the destination as the CIDR range of this particular VPC. So this is the route to communicate within the VPC. So click on edit routes and here we will be adding more custom routes. Click on add. Here destination we should be choosing anywhere, that means 0000, and the target type should be our internet gateway. So as soon as you select internet gateway, automatically the name will come, and select that and click on save changes. Now there is a route for the communication from the outside world. And also in security group, we have already allowed the communication to our EC2 instance. So now we'll try to SSH into our public EC2A machine. And to SSH into the EC2 machine, first we have to change our PAM key to the PuTTY compatible private key format. So here open PuTTYGen and click on load and select your downloaded keypair. I will be leaving key passphrase as blank. So key passphrase is an extra layer of security. Even if someone gets hold of your private key, then also key passphrase needs to be entered to use that private key. But with the use of passphrase, it restricts the automation options. So we are leaving it as a blank and click on save private key. And we'll be saving the private key in the PPK file format. And click on save. Now I will be selecting EC2A machine and copying this public IP of that EC2A machine. Also, if you click on connect, so it will give you the various method by which you can connect to the particular instance. So if I click on SSH client, it is giving me this. I should be using this particular user, that means EC2-user, and with this public IP or private IP. So here I will launch PuTTY software in my machine and put public IP, and then from the left hand menu I will go to the credential, SSH, auth, again to the credentials, and then here I will be selecting the private key file. Here select our PPK generated file and click on open. Accept. Now we have to give the user. So which we have already seen, the user to connect to this machine will be the EC2-user. So now I'm in this machine. So if you see, IP of this machine ends with 212, and here private IP of this machine EC2A also ends with 212. So that means I'm in the correct machine. Now if I select EC2B and click on SSH client connect, then this is the method. So here I have to save the PAM key and then change the file permission and then try to do SSH. So in my machine, if I open the PAM key in a notepad and do a control and control A, control C, and open the nano editor with the respective file name. So I will copy the file name from here instead of typing. And will be pasting it here. And control X and save. So I have my PAM key in place. Now I will be running check mode command. So I will copy this complete command and paste it here and press enter. This is done. Now I will be doing the SSH. So here I will be copying the complete command from here and pasting it here and press enter. But this doesn't seem to work. So any guesses why? I'm sure many of you might have already guessed it. We don't have any security group exception in our EC2 firewall. That means in our security group which is associated with our private EC2 machine. So there we have to add one security rule to allow SSH communication from EC2A. So which we will be doing now. Going to my EC2 dashboard in AWS portal and then going to the EC2B instance and selecting that, and under security I will be going to the respective security group. Click on the security group and here I will be clicking on edit inbound rules. Here there is currently no rule, so here we have to add the rule to allow communication from our public EC2 machine. So here I will be clicking on add rule. Here type should be SSH and source should be custom. Here I will be selecting the security group of that public EC2 machine. That means security group of EC2A. and click on save. Now if I go to my EC2A machine and try to do SSH to EC2B, then here you can see I am able to connect. And if you see here, the local IP is same as here, that means ending with 152. So as per our architecture, we are able to achieve what we have desired. So we have created one VPC and attached one internet gateway and deployed one machine in public subnet as well as one machine in private subnet. And then we are able to SSH into the private EC2 machine using the public EC2 machine as a jump box. So this is one of the most commonly followed best practice by many organizations and many people across the globe, where you keep your secure workloads in non-accessible machine, and if you want to access it, you give the access via any jump box. So the jump box could be a managed jump box deployed by you and managed by you, or it could be a managed service provided by the respective cloud provider. So this marks the end of this lecture on Amazon VPC and all of its major components. So I hope you liked this lecture and you are going to follow me in my next lecture, which is on NAT gateway and VPC flow log, and as well as the peering between two, that means connecting two VPCs. So I hope to see you in the next lecture, and in the meantime also please feel free to provide your feedback on this lecture as well as on the future lectures. Thank you. Hope to see you in the next lectures. Until then, take care of yourself.